Moving on to the sample test, in number 4, we're asked to integrate sine x minus 3 cosine x dx. The most confusing part about integrating these sines and cosines is understanding which negative or positive sign goes with the integration of each thing. So if I think back to how I do the derivatives, if I take the derivative of sine x, the result is cosine x. For that reason, if I integrate cosine x dx, I get back to positive sine x plus c. If I take the derivative of cosine x, that's going to give me sine x with a negative. For that reason, if I integrate negative sine x dx, it's going to give me positive cosine x plus c. So these integration rules, I can always multiply by -1. If I start with negative cosine, I get to negative sine. If I start with positive sine, I get to negative cosine. Where we've started here is with positive sine. So this positive sine needs to integrate to negative cosine x. Here we're starting with negative cosine. If we integrated positive cosine, we would have gotten positive sine. So integrating negative cosine has to get us to negative sine. So negative 3 sine x, and then I need my plus c. For problem number 5, find the particular solution. Basically, a particular solution means we have to solve back for c. So the first thing I'm going to do for this problem is I'm going to integrate what f prime of x was, 6x dx. That becomes 6x squared over 2 plus c, which is really 3x squared plus c. The question is, what's this c? Well, since this is my f of x, and when I plug in 0, I should get 2, I can find that f of 0 equals 3 times 0 squared plus c. So f of 0 just equals c. We also know that f of 0 equals 2. That's how we know c equals 2. So the final equation, f of x with that initial condition, should be written as 3x squared plus 2. Final problem here, use the properties of summation to solve. Full disclosure, I do not have the properties of summation memorized. So I'm going to do what I hope you do on the test, which is bring up slide number 9 from the sigma notation. In slide number 9, it tells me that the summation from I equals 1 to n of c equals c times n. It also tells me the summation from I equals 1 to n of I equals n times n plus 1 over 2. So again, I don't need you to have these formulas memorized. Please have them in your notes ready when you take the test. I do need you to know how to apply them. So basically what this tells me is that I'm going to have 4 times the summation formula for I, which is n, 12, times n plus 1, 12 plus 1, divided by 2. I'm going to need to add to that 9 times 12. So this is a case where you definitely want to have your calculator handy. When I do this in my calculator, 4 parentheses 12 times 13 divided by 2 in parentheses plus 9 times 12. I get this to be 420. Again, make sure that you have the formulas handy and that you're applying them correctly. There might be one with an I squared in there, but I don't think there's anything that's going to get up to I cubes.